Okay, functions, this is a warm-up that we started with today, and I want to make sure that you do know how to go through this. So, again, we only have one log like this on one side, and it's equal to this. We want to use that circle of logs idea and rewrite this to help us solve. So since my base is 5, and a logarithm always equals a power, I can write 5 squared is equal to whatever this is inside the parentheses, so is equal to this. So then this isn't as hard as it looks now. Now I can figure this out. This looks like something that I've done before. Well, 5 squared is 25. So we get 25 is equal to x squared plus 4x plus 4. Well, what does a quadratic need to equal so we can solve it? Well, it needs to equal 0. So I'm going to subtract 25 from both sides. Once I'm done subtracting 25 from both sides, I can factor. The factors of negative 21 that add up to a positive 4 are a positive 7 and a negative 3. And then again, we just set each factor equal to 0 and we solve. So we get a solution of x is equal to negative 7 and 3. All right, so that is what we warmed up with. This was just a review. Again, we need to know how to do an exponential or graph an exponential by hand. Remember, graphing an exponential by hand means that we have to create a table, and we're going to put in our own values, and we need to know how to do the domain, range, and the equation of the line for the asymptote. So for this one, I typically will put in negative 2, negative 1, 0, 1, and 2. And when I do that, so if I did that here, we put negative 2, negative 1, 0, 1, and 2. Well, that means my y, I just plug in whatever my x is to get my y. So for this first one, I would get 1 over 4 to the negative second power. Well, what does it mean when it's on the outside of the parentheses? It means it goes to both. So I'm going to rewrite that as 1 to the negative second over 4 to the negative second. Remember, we need to know how to do this without a calculator. If I have negative exponents, that means I need to make them positive. So I end up with 4 squared over 1 squared, which is 16. So my y value for that one is 16. So make sure you can do the rest of the table. Go ahead and hit pause, and we will come back to this and see if you got it. Okay, so if we do that, let's see. All right, so we should have gotten 16, 4. So then you're going to graph. So 16's off this graph, but when x is negative 1, my y is 4. And then we have 1. And then right there. So okay, let's see if I can do this. We're going to have something that looks something like this. And it is exponential decay. And that makes sense, right? Because my b value is less than 1 but greater than 0. So it's not negative, but it is a fraction. So I know I'm going to have exponential decay. So then when I'm looking at this, what is the most negative that my x value is going to, well, this arrow tells me it's going to go all the way to negative infinity. And this arrow tells me it's going to go all the way to positive infinity. So remember, domain relates to x's and y's, left to right. What values of x's are going to work? All of them are going to work. But y is a little bit of a different story. It looks like it's going to get real close to that x-axis but never get to it. So that means that I'm never going to have a negative y value. So my smallest possible value is going to be, my smallest possible y value is going to be 0. But it is going up forever. So I am going to say it's going to go up to infinity. So my range is 0 to infinity. Now, what is the equation of a line? Well, when it's a horizontal line and it's not going to go, my y value is always going to be 0, so I'm going to have y is equal to 0. So make sure you do remember how to do that and that you can do that. All right, so now let's do logarithms. So, one thing I want to say. So if this is an exponential, the inverse of an exponential is a logarithm. So if we were to graph a logarithm by hand, we want to think about it as an exponential, the inverse to the exponential. So we're going to kind of flip everything that we've done. So the first thing we're going to do is that we're going to rewrite this as a y equals, and then we're going to rewrite it as an exponential because we know how to do that. So then we get 4, so if my base is my base is 4, my exponent is y, and my answer is x, So then I'm going to get 4y to the x, which means I'm going to put my -2, my -1, my 0, my 1, and my 2, all on my y's. I'm going to plug it in for y to find my x, because remember, a logarithm is an inverse of an exponential. So when I do that, let me delete that. Oops, I don't care. Let's see, I think I can do it faster. Okay, when I do that, I plug in those numbers for my y, and I get my x values. So right there. So then when I graph that, be careful when you're graphing, make sure you're graphing it correctly. So when x is 1/16, so about right here, y is -2, which is right there. And when x is 1/4, so about, I don't know, right there, y is -1. And when x is 1, which is right here, my y is 0. And then when x is 4, so 1, 2, 3, 4, my y is 1, right up here. And then x is 16, and it'll be 2. So my graph, let's see if I can draw this. My graph is going to look something like, something like that. Okay, again, just be kind of lenient with the shape. I got the right thing. So that means my domain has changed now. So if I switch the x and the y and I did all my y values and I'm thinking of the inverse, my domain is going to be, well, never going to have any negative x values. So I'm going to have 0 to infinity because it goes this way forever. But then my range, it goes down forever and it's going to go up forever. So my range is going to be that -infinity to infinity. And that makes sense. We switch the x and the y, then we switch the domain and range, and it makes sense. So then my asymptote is going to be the y-axis, is a vertical asymptote. So then we're going to have x equals 0. Because no matter what my y value is, my x is always going to be 0. And that is how you write the equation of an asymptote when it's a vertical asymptote. So it's going to be x equals 0. Okay, so that was a really quick recap on graphing. We are going to practice this more in class. If you have questions, please come to class with questions. It's really amazing when you guys do that. All right, so now we're going to look through this one. So using the properties of logs to rewrite. So we have this long thing. So what we're going to do is we're going to rewrite it. The first thing I'm going to do is rewrite it as an exponential. So the first thing we want to do is rewrite with the exponent. So the number, so exponents. So now I have all of this. So the 2 in front of here became that. So we do like the reverse power rule for everything, right? Then the next thing I want to do is I want to rewrite using properties, but I'm going to start looking at it left to right. So I know that I have addition right here. Addition is the product rule. So the product rule means that I'm going to do multiplication. Notice that I still write the minus sign. I still have this because I didn't do anything with those. I only took care of those. But my minus sign right here tells me that I'm going to be doing division. So now I have that. So again, my log stays out here, just like it did right here. I'm reducing it down, and I'm making my answers go together. So this minus sign right here is this division sign right here. And I'm going to use a different color. Blue. Okay, so now I have another division sign right here, another minus sign, which means I'm going to have another division sign. So that's this division. Let's see if I can get it. That's this division sign right here. So this one is right there. So now I have all of this is in my numerator divided by z cubed. Now, when we have a fraction within a fraction, which is what we have here, we have one fraction within a fraction, that can be rewritten. We could rewrite all of this so it looks a little more familiar. Here, I'll do a different color. I'll do green. So we could rewrite this technically like this: log base a of w squared x to the 1/2 over y to the 3/2 divided by z cubed. Well, no, this looks like a rational expression. It is a rational expression. We have to keep this one the same. We want to change this to multiplication. And remember, we're going to flip this. So this is actually going to be over 1. We're going to flip this. So if I go to the next slide, I've kept the fraction the same. I changed it to multiplication, and I flipped the fraction. So keep, change, flip, that rule does not go away. When you divide a fraction by a fraction, that is what we're doing. And if you see a fraction within a fraction, the way that we saw it over here, that's what that means. So when I do that, then I end up with, and again, remember when we're multiplying, top times top equals top. So anything times 1 is itself. And then these two things are being multiplied, so they stay in the bottom. So that is one way to do it. And now that you've seen it a little bit the difficult way, like if you can't remember, there is another way. So we can, let me see if I can erase all of this. Erase all the ink on the slide. Okay, so if we start here, right here, so you still want to rewrite with the exponents, but we can, however, let's change them all to addition. So if I do that, I'm going to put this here, and then, but that means the negative's got to go with the exponent. If I turn this into addition, then that means this needs to go with the exponent. So then I can rewrite it, and we know every time we see a plus, we just multiply. So log base A, have my parentheses, I've got w squared, plus means times, right, when I'm rewriting, oops, plus means times when I'm rewriting, so times, and then I've got x to the 1/2, then I got another plus, so times y to the negative 3/2, plus another one, so times z, oops, hold on, z to the negative 3rd, and then I'm going to close my parentheses. Okay, so now I've reduced all of that, but I've got negative exponents. I don't want negative exponents. How do I make them positive? Well, I just move them. So then I end up with log base A of w squared x to the 1/2, because those are all positive, and then I got to move this y to the negative 3/2 to the bottom, so now it becomes positive. And I got to move the z cubed, or negative 3, to down here, and it becomes positive, and then I just have to put all of this in parentheses. And that is my final answer. So notice that we get the same thing, but we have to make sure that we do either what I did the first time or this one. So if you have any questions, please come to class, ask Ms. Wadley, ask myself, ask a trusted math teacher. I'm sure that they can help you. But I hope you all have a great night. I will see you tomorrow, and don't forget the test is on Tuesday.